In section 8.5, we're now going to do hypothesis testing with means. And at least in this class, we're always going to assume that we don't know the standard deviation of the population, which means we'll use a t-test. Okay, so the first hypothesis we're going to test is that new baseballs don't bounce as well as old ones did. Okay, so to test this claim, we need to know stuff about old baseballs and then do a sample of new baseballs. So the old baseball information, it says when dropped on concrete from 24 feet above, the old baseballs bounced on average 92.84 inches. Now, the 24 feet above, that's just telling you how they did it, but it's not actually important for the problem. So the new baseball sample information, it says 32 new baseballs, so that's our N, were dropped, again, from 24 feet. And it says the mean bounce height was 92.30, so the mean was 92.30, and the standard deviation was 1.79. Okay, now we want to know were the new ones less than the old baseballs. So new baseballs, our claim is that they bounce less than the old ones, and the old ones bounced 92.84. If that's a less than, of course, the null will be mu is equal to 92.84. And we're going to choose a significance level of 5%. Okay? So now to do this, you go to the same place that you did for the proportions. You're going to go stat, test, and this time you're going to choose t-test. It's number 2. Okay, and for this we're going to put in stats. So you'll want to choose stats. So for m, our mu0, that's what we use for our null and our alternate, so that's going to be 92.84. We know our x bar from the sample was 92.30, and then where it says sx, we're going to put in 1.79. And our standard deviation from the problem was 1.79. So now I'm going to talk through, because I already have some of this written here. That our n was 32, and we want it to be less. Our claim is that they don't bounce as high. Okay, now from our calculator, we get t is negative 1.71, and p is 0.0490. Okay, and the alpha we chose was 0.05. So since our p-value is less than alpha, we reject the null hypothesis. And since our original claim was H1, we support H1. So formally we'd say we reject the null hypothesis, which means we support the claim that new baseballs do not bounce as well as the old ones did. Okay, now our next claim says that male symphony conductors live longer than the average male. And we're told that in the general population, the average lifespan of males is 69.5 years. So if we're talking about symphony conductors living longer, our claim would be that mu is greater than 69.5. Okay? And our null is that mu equals 69.5. Now, we have a sample of 35 random male symphony conductors. They have a mean age of 73.4 years. And a standard deviation of 9.7 years. Now we're going to use a significance level of 0.01. So you're going to go to the t-test on your calculator, and for mu0 we're going to put in 69.5, and for x bar, the mean from our sample, we're going to put in 73.4, and our standard deviation from our sample is 9.7. And we surveyed 35, so our n is 35. Okay, now for our sample, remember our claim is that they live longer, so mu is greater than mu0. Now I'm going to choose calculate for our t value. We get 2.38, and for our p-value we get 0.0116. Okay, so remember our alpha here was 0.01, so since p is bigger than alpha, right, we do not reject the null hypothesis. Okay, so since we don't reject the null hypothesis and our original claim was the alternate, we do not support H1. So our final statement would be, we do not support the claim that male symphony conductors live longer than the average male. Okay, and for our third example, the claim is that the average weight of a bumblebee bat, which is the world's smallest mammal, is 1.8 ounces. So since this is an is statement, our claim is the null hypothesis that mu equals 1.8. So our alternate would be mu does not equal 1.8. Now we're given something a little different here. We're given the weights of 15 bumblebee bats. So we can still put this easily into our calculator. You're going to go to L1 and put in those 15 values. So remember, stat, edit, and you're going to put in the 15 values here in the notes. Okay, then you're going to go stat over to test and choose t-test number 2. And you want to have it on data, okay, when it says input. So then for mu0, remember from our claim was 1.8. For list, you want to put in L1, and the frequency you're going to put in 1. Remember that our claim is that mu does not equal, well, our alternate is that mu does not equal mu0. So then when you choose calculate, it'll give you a t-value of negative 1.30 and a p-value of 0.2155. Okay, so if alpha is 0.05, okay, p is definitely bigger than alpha. So since p is bigger than alpha, we do not reject the null hypothesis, and the null hypothesis was the claim here. Okay, so our conclusion would be we do not reject the claim that the mean weight of a bumblebee bat is 1.8 ounces.